Thank you. And so let's continue. Any questions about what we had so far? Okay, so we have this this code. Now, one of the things this library. So one of the things that is very valuable for programmers is the capability to verify your own code. And if any of you know people from the high-tech industry, you probably know that there are, in many companies, there are usually the developers, programmers, whatever we call them, and then there is a separate group of people, a separate department usually, which is called the QA, quality assurance. And in many cases, what they do is in the company that the programmers write some program, and then they pass it over to the QA people, and they are using the program as an application. It's usually something like it's not just source code. They already get the ready application, and try to verify that that everything works fine. There are a couple of problems with this thing in the high-tech industry as well. One of them is that if there is any issue that comes up, it's long after the developer worked on this code. So the developer works on the code for 2 weeks, let's say, and then the QA people start checking, and 2 weeks later they find some bug that the developer maybe wrote now already 4 weeks earlier. So it's very far. Since then, many things might have changed. The programmer doesn't remember, and so on. So that's one big issue, the time difference. Another big issue is that as the program grows, how can you verify that when a new changes was made? Okay, so let's say a new feature was added to the program. How can you, and then the QA people go ahead and verify that that new feature works as expected, but can they also verify that nothing else broke? Okay, so all the old parts are still working. I mean, they could go over all the program, but as the application grows, as the program that people write grow, there are going to be more and more features, and in order to verify everything will take more and more time. So this whole cycle, the development QA cycle, will just be longer and longer because the QA will be longer and longer. Or what will happen actually is that they don't check, they don't verify all the old code. They say, well, we assume that everything works fine. Okay, and if any of you have ever used any software, which probably you have, then you know that there are all kinds of problems with all the applications you use or the websites you use. There are always problems. Something goes wrong, and then maybe it's fixed later, maybe it's not, but things go wrong often. And that's part because people made changes and they didn't check the old version. Now, for you, it's even worse because you don't have a QA department. You are only the programmer, okay, in this case. So you write your code and then you try to use it also. So basically you are your own QA department in that case. Or you give it to someone else in the lab and then they try to use it, but there's no like organized quality assurance. It's not lately, but like at least 20 years we already know, but many companies don't use the idea of the programmer writing a little bit more code that will verify that the application works as expected. Okay, so these days it's much more popular, but still a lot of companies don't employ it and don't employ it enough. We could, and that's what we're going to do now, we could write what we call tests, automated tests, which is basically some more code that will check whether our application still works. Okay, in many of in the high tech, usually what they say is, okay, they're trying to replace the QA with this, but that's not really the real thing to do. The real thing to do is the real valuable thing to do is to verify what I called earlier business logic, the computation part. You remember I told you that it's a good idea to separate the three main parts of the program. One part is getting the input, okay? So from the user especially, that's one part. The second part is doing whatever calculation we need to do. That's what we call business logic, even if it's not business, but if you are, even if your business is doing research, okay, or doing experiments, that's sort of the business logic. And then the output, displaying something to the user. The real value is verifying that the business logic, the real value is verifying that the business logic works. What do I mean by real value? That's where it's a good trade-off, okay, investing more energy in trying to automatically verify things. Unfortunately, companies try to replicate the QA people by programs, and that's not really working well. So we are going to run now. So we have these three files now. The Fibonacci, which is basically getting the input from the user. Okay, but it was getting the input for the user, and I've commented out, and then the printing. And it was calling the computation, which is in the separate, in the MyMess library. Same was with the add, okay? This is sort of, it doesn't have getting the values from the users, it doesn't have input, but this would be here. I'm getting the input from the user, and then I'm passing in to the add function. So what we are going to do is verify these functions. And in order to do this, we're going to, okay, one way to verify is to create an application like this. Okay, let's continue with this. Import sys, and then type in, let's say, int sys argv1, and then the same with sys argv2, and I don't even verify. What do I get? I run cd day 05, and I write Python 3. What is add numbers 2 and 3, and I look at it and say, oh, it's 5, it's working. Okay, and I try it with 2 and 2, and it's working. Okay, let me show you another example. MyMess. Let's do the function def area. Okay, which gets the width and the height of a rectangle, and returns width plus height. Okay, now let's try this. Okay, let's write a small.
You need to multiply the width and the height.
You already found my bug. I wanted to show you exactly what happens. Okay, well, thank you.
Sorry.
No problem. No problem. That's so area. Okay. What happened? Why doesn't like me? MyMess. Oh, because it's I didn't save the file. Now you see, I have the same issue that earlier we had, but it's now I think it's because I didn't save the file yet. So it's, you see, it's not saved yet. So saving it, it's called area. Okay, let's call it area. Okay, so how do I try this? I say, okay, area 2 and 2, and it's working, right? It's correct. So even if you are verifying sort of your thing, you might verify a few things. Okay, in this case, one thing I verified, and you get the right result, and you're happy. Even though we all know now that it's not that is in reality, in some cases, in this program, in many cases, in most cases, but in other places, in some cases, the bug, it will be buggy, okay? Now, I couldn't come up with an easy example that would show that it worked most of the cases, but not some cases. So this is why I came up with this example where in one case it works, okay, and in other cases it's not, okay? So let me add here, so I know there is a bug here, okay? Just to clarify it. Okay, so let's test it. Okay, in order to test, we create a new file, and we are going to save it, and we are calling it test mymath. Let's say mymath.py. Okay, the name doesn't matter. The only part that is important in the name is that it starts with test underscore and then some word. Okay, so the test underscore is the critical part. What comes after it is not that important. I use the name mymath because that's what we are going to test, so it makes sense. Okay, so now what I'm doing is basically using the program. I am saying, okay, import mymath, okay, and here I'm going to write a test. So I create a function which is called test something again. Test add, okay? What the important in this function is that it is called test something again. It's what does it call? It's not important, but again, it's useful that it describes what you are doing. So here I do the calculation. mymath 2 and 3, 2, 3. And I get back a result. Okay, so far is good. And now I would like to compare if the result is what I really expect. So I need for this to some way compute what should be mymath. It's not mymath, it's mymath.add, right? So the result should be 5, right? So what I do is I say assert, and I say result equals to 5 with double equal, okay, because it's checking whether they are the same, okay. So let's run this program. How do I run this now? You might notice that there is no calling this test add, and that's because it works. This whole testing system works in a totally different way. Let me see if it's even installed. Pytest. No, it's not installed. So we need a library called pytest. How do I install it? Well, I need to do this first. Okay. Okay, you don't need to do this. I need to do this because I have some configuration. You install pip install pytest. Okay, and I need to type it, of course, correctly. So what it does first, you see these lines, it was installing first, downloaded pytest, it noticed that it noticed that the requirements were already satisfied, and so it installed it. That's it. And let me put here in the README before I forget. Pip install pytest. Okay. Where are we? Test mymath. Okay. So now that we've installed it, I can try to run it again. And here it is what I got back. Okay. So what do I see here? I get a report. It says that it ran the test mymath file. Okay, that's test mymath. It found that one. This dot indicates that it found one test function. Okay, a function which is called test something. And it's dot, meaning and it's also green in case you don't see it, which means it passed. Okay, that the test passed. This assert keyword is a new keyword that we haven't learned about. It's basically getting something here which is either true or false. Okay, so this result equal to 5 is either true or false. And it will report basically, I mean, it will raise an exception. That's the official or the real thing that it does. But it helps this whole pytest system to notice that this, whether this passed or not. I will show you in a few moments how it looks when it fails. Okay, but so far what we did is we did this computation and we verified that the result of this is 5. Okay, now it doesn't prove that this add function works for every time, right? I just picked up one example and I verified that one. And here comes now the idea that you, as basically the programmer, have to think, okay, what kind of cases I would like to verify, make sure that, okay, this works, that works, and then I can say, okay, if this and this and this works, then I'm fine. Okay, then probably it will work for everything. It's usually, we call them edge cases. So let's say I try, okay, what if I -1 and +1? Okay, and of course my expectation now is 0. Now what happens? It's still 1 dot, right? Because I still have one test function. But everything passed. Let's say I would like to have more of these. So let's say I create a new, you know what? Yeah, I would like to test now the other function, the which one? Test area. Okay, so my mass area. Okay, 2, 2, the area should be 4. Okay, so I run it, and now you can see 2 dots, right? Because there are 2 test cases, 2 test files actually. One of them verifies 2 things, but that's fine. 2 test functions. Okay, and this way now I verify that the area is working for that input. But of course we know already, okay, that it's actually not correct. It's broken. So, but if you're satisfied with this version, okay, let's say you wrote this and you verified it, and then you give it to your to the head of the lab, and the head of the lab says, well, for some other numbers it doesn't seem to work well. Okay, so the head of the lab comes back and say, well, if I try to calculate the area of 2, something which is 2 on one side and 3 on the other side, it gives me the incorrect answer. So, of course, you don't believe, but you say, okay, let's verify. So I'm going to add a new test function here, test area 2, okay? And they will say, okay, if I had 2 and 3, and that should be 6, right? Because that's the area. I mean, I have to know what I'm expecting as a result. So let's run this again. Oh, and it fails, obviously. Okay, we know that it's obviously it fails. And it says, the assertion says that on the left-hand side I had 5, on the right-hand side I had 6, and they are not equal. So you can come back to you can even look at this. Okay, it shows here, but if it's much bigger, then you can come here and look at it and say, okay, so I was trying to calculate 2 and 3, the area of 2 and 3, which was supposed to be 6, but I got back 5. And now you have a failing test. And what does the test say? It had 2 dots because the two test functions, this one and this one, passed, and one was failing. This one failing. Okay, the third one actually. And here you can see exactly what failed, in which line, what was the one side, other side. You can see a summary of all the report and so on. Okay, so now of course.
Can I ask a question?
Sure, of course, yeah.
What did you do to see the report of the test in the terminal? Because when I run my code, it just nothing happened.
So you don't run this program. You notice I didn't run the program. I just said pytest. I didn't mention the name of the test file. Okay, well, let's take a look at your screen and then we can see it. But so this is it's a totally different way of how things work. Can we take a look at your screen?
Yeah, I cannot share.
Wait a second. I have to stop my sharing and then
Okay.
So the first question I just in general, in theory, I ask if you can share.
Okay. Can you see?
Mm-hmm.
So you see, I did like my math add and then assert, and if I now I understand I should not run it this way.
No, because you don't. First of all, you see, you don't call the text. No one calls the text add function, right? When in your code, you don't call the test add function, so nothing should really work, right?
Okay.
But it's fine that you don't call it because that's how we work. Okay, how these things work. So now type in pytest.
Just like this?
Yeah, just and enter. Yeah.
Oh, I see.
Okay, now what does it say? Can you scroll a little up yeah. PyTest, the term PyTest is not recognized. Okay, so it's not installed in your computer.
Oh, okay.
Okay, so now go ahead and say pip install PyTest on the command line. Pip install. It wasn't installed on my computer either, right? Because it doesn't come with Python, this library.
Mm-hmm. I see.
Okay. Same thing. Now you can run again the PyTest. Okay. So what happened now? It says that it couldn't find any test. So it still couldn't find. Why can't find it? If you look up your name, the name of the file is test mymess. It's not test underscore mymess.
Oh, I see.
Okay, so click on the left hand side. You can click and press F2 or rename. I think and put an underscore there.
That's it, like this.
Yeah, and run pytest again.
Nice.
Okay, so it has to be called test underscore because so the pytest. Okay.
Okay.
Good.
Thank you.
You're welcome.
Can I ask a question as well?
Sure. Everyone.
Yeah, if you have time, that's the question.
Yeah, sure.
You did for each assert, you made a specific function. Can you put more than one assert in a function, or put maybe a loop that tests a lot of numbers inside the function and do the assert if this is possible?
Okay, so first of all, in this one, in the first test, I already have two asserts. Okay, you can put as many asserts in any test function as you like. Okay, and it has advantages and disadvantages. So the advantages, of course, that you don't have to come up with all kind of names, function names. That's one of the advantages. The disadvantage is of putting many asserts like this in one function is that if one fails, so let's say here I put here another. So let's say I don't have in this test area I have so instead of this, let's comment this out and copy this one just here and in this order. Okay, so if I run this one now, it will say that one of them was successful, the other test function failed, and this one wasn't even tested. This I don't know what happened to this. So I mean, the report doesn't. From the report, I don't know. Factually, I know that because this assert already failed, this test case wasn't even executed. Okay.
So if you wanted to continue, you would do maybe a list and add the results into the list and then do the assert on the entire list, for example.
So there are a couple of ways you can do, a couple of things you can do. One of them is so wait a second before I get before showing the solution. When should you put more assert into one function, and when you shouldn't? The general rule is that you should one test case in one function. Okay, so for example, you download, your application is generating a huge report, okay, with a lot. That's what your program does. It creates a string, a text, which is a big report, and you don't. I mean, theoretically, one way to test is to take the big report and compare it one-to-one exactly to the generated report. So generate this report once, let's say, and then to save it and say, okay, now any time I run this report, I have to get exactly the same thing. But if this report has lots of this meta thing around it, like colors, okay, and you don't really care about the color, let's say you as the programmer, okay, you only care about the actual result of the numbers in the report, okay, and not in the colors and whether it's on the left side of the screen or the right side of the screen. You don't care about that because it's just the niceties. You care only the numbers. So you can't compare it one-to-one. So what you do is generate the report, and then in the same test function, you verify each number separately. But because they belong to the same test report, you put them in the same function. So they are connected to each other. Okay? As opposed to what we have here, that these are totally separate test cases. Okay? They are independent from each other. Right? So that's sort of the general rule I try to follow, that to put in one test function asserts that are dependent on each other, and put them into separate functions if they are independent. So whether this one works and this works, they have nothing to do with each other. One of them might work, the other one not. Just as we saw here, that these two codes are totally independent. So how do I solve this case where I have many same test cases? Okay, so there's many test cases verifying the same function, this one. So how can I improve this one? And for this, I can do, let me copy this again. So we have basically just so we have the old one, test add parameterized. Okay, now let's see if I remember. If I don't, then I'll have to cheat and look it up. For this, I need to import pytest. Okay, pytest. Okay, pytest itself is both something that you can run on the command line, but you can also import it. And for some reason, it complains. But why? Oh, because of this. Okay, so pytest. No, I don't remember. Okay, let's look at the example. CodeMaven, slides, Python, pytest. I think it's this one. Parameterize. Okay. So this is what you need to do. Okay. And okay, so this is also a good example. You don't have to remember everything. Okay, you just know where to find how it's written, and that's one part of the reason I writing many of the articles. So this is how you add parameters to your test. So here we have the parameters. In this case, I have what do I have here? this one. Width and height, right? These are the two parameters of this of the add function. So not x width and height. Just let's say x and y. Okay, these are the two parameters, and then we add the test cases. So this is how you add the test cases. 2, 3, and whatever, -1, +1. Okay, so this way, what I did, I said, okay, this test function is going to be, the fact that I called it parameterized is just because I had to give it a name, okay? This is the critical word here, okay? So I added test cases. And inside the program, now I'm saying, okay, I'm expecting here, I come back here. So here you see in the test, let me enlarge it. In the function itself, I put these, the same words that I used here. These are going to be the parameters of this test function, or the test function. So I'm getting, in this case, x and y. And then I can use these variables and pass them to the add function. Wait a second, I need to have 3, right? I need to have 3. I have the result, let's say. Expected. So the expected result is 5. The expected result is 0. So I have now 3 parameters, expected and expected. Okay, so what I have here, what do I have here? I created test cases here. Okay, what I said is here, these are the parameters of the test function. The parameters in our case are the 2 values that should be the input of this add function and the expected result. And I said, okay, I call them x, y, and expected. And here I said I had to say that the test function is going to receive these variables x, y, and expected. We call the add function with the 2 input parameters, get some result, and then compare the result to the expected value. So let's run this program now. PyTest. Okay, the test area 2 failed. But as you can see, now I have an extra dot here. Okay, this is this test program. This test function, sorry. The last dot. Let me first of all put this PyTest at the top. Okay, I don't know why it's yellow there. No, it's really strange why it can't, why it complains. Maybe I have to. I think I know why it's complaining. Okay, it's complaining now. It's complaining because you remember I said that I did something. This one, right? This command that I said you don't have to do, and this is because I have separate environments. And the reason this yellow thing is here is because Visual Studio Code doesn't see this new environment where I actually installed PyTest. I think I told you about this at the beginning of the course, that this is one of the issues of having multiple Pythons installed on your computers. Well, or multiple environments. Well, this is what actually I got. I installed PyTest in one environment, and it's working on the command line because it looks at that environment. But Visual Studio Code actually, as it is right now, it doesn't look at that environment. So I would like to solve it because before I continue explaining how we parameterize it, So the solution is rather simple. I close it. Go to the terminal. Run this source thing. So I turn on my environment. That's what I do here, okay? And then I start Visual Studio Code. And I think that will solve the problem. I'm not sure, actually. Yeah, it solved it, okay? Okay, it solved it because now Visual Studio Code sees that Python, that environment. So it's not yellow here anymore. Okay, you probably won't have this problem unless you have multiple versions of Python installed. So coming back to this, I'm trying to show you that this really works. So let's add a new test case here. Let's try and expect here 3, okay, just so it will fail. So now I run this pytest, and it reported, you see, if I scroll back a little bit, now I have an F here for the last test function as well. Okay, so this whole thing got one single dot or one single F, okay? But it actually, what this does is runs this test function 3 times, 1 for each one of these set of values. Okay, and then I parameter, this is how I parameterize the function. In the report, I even get this. It says that this function, so the test area 2 failed, fine, but also the test at parameterize failed with these parameters. Now it's -1, this minus, it's a little bit confusing how it looks like. It basically gave it some name. Let's make it +1. It still failed. It should still fail, but it might. So these dashes are not minus signs. Okay, they are the same character, but it was the intention is just to separate the parameters. Okay, so it tells me that this test case fails, and this is asserted 2, and one left side was 2, the right side was 3. And then you go back and you see the result was 2, the expected value was 3. Okay, did it answer your question? Okay.
Yeah.
Okay. Okay, good. If we are already here, let me show you something fun. You can actually take this name. Okay. I copy it, and then I can say pytest and paste it. And I might need to put the whole thing into quotes, because the square brackets have meaning on the command line, so I had to put it in quotes. What now did, I ran only that specific test case. So it only, if we now look at the report, it says 1 single F. It only ran that specific test case, not even the 2 others. So it didn't run that test function, it ran that specific test case of that test function. Okay, it can be very useful, especially when you have lots of tests. That takes a lot of time. One of them, let's say, fails. So now you would like to rerun that same one several times while you are trying to fix the code. And you don't want to run all the others while you're fixing the code, because that would be wasteful, right? I mean, now it's a couple of seconds, but it might take minutes to run all the tests. So you don't want to waste your time while you are focusing on one thing. So now, let's say you fixed it, and then you rerun all the tests again, to verify that by fixing this, you didn't break anything else, right? But you can this way focus on one very specific test case, and even if it's parameterized, you can check that one. So it's quite valuable to do this. What else can I tell about testing? So let me just point out what we did here, really. So, and it's also trying to clear a misconception that you might not have yet, unless you heard from people from high tech. QA, okay, what I told about, QA was sort of about finding bugs and verifying that there is a quality in the program and so on. And people sort of think that that writing tests is to find bugs in your code now. That's not the real goal. The real goal is to make sure that a week from now or an hour from now, okay, even if an hour from now or a week or a year from now, okay, when you need to make some changes to your code, you can easily verify that you didn't break anything that was working earlier. Okay, so if I write, I mean, I know that the add function, let's say, works. Okay, the area function less so, but I know that the area of the add function works. So what's the point of writing these tests? Well, the point is that when I later on go on and implement a much better version of the add function, okay, I would like to I would like to ensure that the much better version of the add function that does it way faster, okay, still gives me the same results. Okay, and obviously the add function might be not a good example for this. But if you go back to the Fibonacci, we had two implementations of the Fibonacci. One of them was working recursively, if you recall it, my mess. Okay, this was working recursively, so it was calling itself, and this was non-recursive. The recursive is way, way, way slower than the non-recursive, like a lot slower. Okay, on big numbers. On small numbers, doesn't really matter much. Okay, on big numbers, you will see that this one is way, 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 way slower. Okay, so maybe someone implemented this one. You used the one that was working recursively, and then you started to complain that it's too slow. So someone went ahead and implemented a non-recursive way and replaced it the same. So replace the function, the same function name, but this case, the implementation behind it, it's non-recursive and still returning the same, supposed to be returning the same values. But how can you verify that they are still returning the same values? Okay, the easy way at the end, this is the easy end. So at the end, it's way easier and way cheaper to write these tests. Unfortunately, even many high-tech companies don't do this, but well, that's another story. Okay, so the easy way is to write these tests as you are implementing your code, and then when you need it, rerun the code. And just to finish this idea before we get to another break, it's not even that you changed your code and you would like to verify that it's still working. It's also, well, first of all, this source code, it will go from hand to hand in your lab. So you write some code and you give it to someone else. How can they verify that everything still works? They might not know all the interesting parts of your code, all the features of your code. They're only focusing on one specific area and might be breaking all the rest. So the one way that you can help them and you can help them prevent breaking your code, breaking this code, is by creating these tests and providing these tests together with the application in the same version control system, in the same GitHub repository. But it's not only that they might change your code or you might change your code. Your code will use many, many libraries from the outside world, like the BioPython I just mentioned. You will probably use that one or hundreds of other of these libraries. And you're going to use a specific version, and you're going to work with them, and you'll say, oh, it's fine. And then one day, you will notice that they have changed their library and gave it and included a new feature in it, let's say, that you need in your code. Or maybe they said, oh, now we improved the performance of our functions and they are 10 times faster. So you would like to get the new version of that, and you install it. But how can you know that your code is still working with the new version of their library? You can test them manually, all right? But who has time for that, right? Really? And it's very error prone to try to verify manually. If you already wrote some of these tests, then you just rerun the tests, and then you say, okay, all the tests that were passing earlier are passing now, so I'm reasonably sure that everything is fine. Okay, that's sort of, you can't be 100%, right? But you can be reasonably sure. And what is reasonable? That, of course, depends on your personality, and it depends on the cost of having an error. Okay, of course, if the cost of having an error somewhere is low, then you will write few tests. If the cost is huge, okay, let's say you are writing the software for an airplane, okay, then probably you will invest a lot more in verifying that your code works. Okay, so that's it. Let's have 10 minutes break. In the meantime, think about more questions.
I have a question.
Oh, would you like to ask it now and then we delay the break now? It's fine.
I can ask it later.
Okay,
I can ask it when we come back.
Because we are on at 11 o'clock, and
okay,
then
thank you.
You are asking the question after it. Okay, so thank you, and please like the videos in YouTube. Thank you. Bye.